itself, right? E to the x times natural log of e. But what's natural log of e? 1 again, right? This is 1. And that means the answer is e to the x, which means it's itself. That's what I was telling you earlier, is that the very important property of the function e to the x is that it is its own derivative. This is the only function in the universe that has that property. There's no other function that is equal to its own, that the derivative is equal to itself. All right? There's no other function that's like that. Well, I should say there's no other non-trivial function. If I give you this function, f of x equals 0, what's the derivative of this? 0, right? Because 0 is a constant, isn't it? So what's the derivative of 0? 0. So that's itself, isn't it? But this is what we call a trivial function. Because what does that function look like when you graph it? It's just a flat line, right? It's just boring. There's nothing. Who cares about that function? It doesn't do anything, right? So we would refer to that as a trivial function. So is there any non-trivial function that is its own derivative? And that is the only one. The only one. You're never going to find another one, okay? That is it, okay? Now, I'm going to continue with some derivatives, but I really want to point out again to you what this actually means, okay? Like, what does that really mean? So what I'm going to do is I'm going to go to Desmos, maybe. Why am I not connected to the internet? I've been having this trouble lately. Connect. Continue connecting? Yeah, connect. That's real weird. Okay, I'm just going to have this graph, e to the x. I'm going to zoom in here a little bit. I'm going to plot some points on here for you. Okay, that's just the e to the x function, all right? Let me do this. Whoa. I can't type today. Why is it not? Get that out of there for a minute. Okay, I'm going to plot some points here. Okay, those 2 points live on that graph. Okay? If you plug in 0 into this function, plug in 0, you get e to the 0 is 1, right? If you plug in 1, e to the 1 would be about 2.718. You could do that on your calculator, or just believe me, right? So if I now ask you to tell me what is the slope of the tangent line right here, what is the slope of that tangent line, you would have to go find the derivative, wouldn't you? But it is its own derivative, which means that the slope of this line is actually just what? 1. It's actually just the height of that point. The y value of this point is actually the slope of the tangent line. That's exactly what it is. No other function is like that. Only this one. If I go here and I say, hey, what's the slope of this tangent line? What is it? 2.718. The slope is equal to the y value of the point that you're at, because it's its own derivative, right? Right, so let me back up. If I asked you to find the slope of this line right here, right? If I say, hey, go find the slope of that tangent line, what you do is you take the derivative of this, right? So what's the derivative of that? Well, itself, right? And then what would you do? You would plug in the x coordinate, 0, into this derivative, and you plug it in, you get your answer, right? And that would tell you the slope of the line. But that's exactly the same as the y coordinate of this function. If I try a different function, like 2 to the x, there's 2 to the x. Let me take the e to the x out. If I do that function, it doesn't work. So if I try this function, zoom out a little bit. This is 2 to the x. If I tell you to go to this point right here, the point 2, 4, and I ask you for the slope of the tangent line, the answer is not 4. The answer is not just the y coordinate, because this is not e to the x, this is 2 to the x. If you want to know the slope of the tangent line, you'd have to take derivative of this, which is what? 2 to the x times natural log of 2. So now you could plug 2 into that. Here you would get 4, but then you'd have to multiply that times natural log 2. So it's almost, this is almost the answer, just you got to tweak it a little bit, right? The historical background on e to the x is actually pretty cool because we had to go find it. It wasn't like given to us, right? It's not like on the back of some book someone found, oh, it's e to the x. Like we had to actually go find it. That's the 2.718 comes from us trying to go figure out what function behaved this way. Like we had to actually come uncover it. And it's the reason we call it the natural exponential function is because we can't really explain why that's the number that makes it happen. Like just kind of naturally is. Just like for the same reason that pi is pi, right? There's no explanation as to why pi is the ratio of a circumference to a diameter on a circle. It just is, right? It's just naturally that way. So, okay. Want to do some more examples. How about this? Find the derivative of x squared e to the x. What are you going to need there? Product rule, right? Product rule. Derivative of the first times the second plus, what's the derivative of the second one? What's the derivative of e to the x? E to the x, right? Nothing else. Just say e to the x, that's it, you're done. Times x squared. There's your product rule. A lot of times you will see textbooks do this at this point. Actually, we can pull out more than that. What did I do there? Factor, which is GCF, right? Just pull a greatest common factor out. Both of these terms have an x. Both of these terms have an e to the x. So pull that out. You'd be left with 2 plus x. How about this one? Okay, haven't done one like this yet. What do y'all see there? What does that look like we're going to need to do? Composition, right? You have this thing right here that's getting plugged into the e function, right? So this is like e to my hand, right? What's the derivative of e to my hand? e to my hand. But then times the derivative of my hand, which is going to require, what's that going to require when I take derivative of that? Product. So the derivative of this is itself, is exactly itself, don't write anything else, times, now you have to take derivative of what was up here, which is a product rule. Since it's a product rule, I'm going to put the answer in parentheses because it's going to have two pieces to it. It'll be the derivative of the first one, so derivative of x is 1 times sine x, plus the derivative of the second one, cosine x, times the x. That's not what I meant to do. Oh, y'all all right with that or no? Yeah? Yeah, sure, no questions? Y'all want to do a quiz on this right now or no? Are we that good with it yet or no? Not yet? Okay. Next time? We'll do next time. Oh yeah, I just give you a couple of these problems like this. Yeah? Next time? Yeah, we'll do that next time. I haven't really been able to give you a quiz because there's nothing quick that I can give you. Nothing that'll take you 5-10 minutes. Like those word problems take a long time, so I can't give a quiz, which is why I'm giving you a take-home quiz, right? So you can take your time on it. All right. Let's go look at the notes. I want to see, make sure I've got everything I want to talk about here. Still got a little bit of time. Nope, that's the quiz. Where'd you go? Where'd you go? Yeah, that was it. Derivatives. Let's go look at an old test. There you go. Why don't you take the next 18 minutes, see if you can do those. All right? If you finish them before 18 minutes is up, then you can just come show them to me, and you can go if they're right. For all of these, I want the derivatives, all right? So there's all sorts of different things in here. There's chain rule, there's product rule, quotient rule. Well, there's no quotient rule. So these problems were taken directly from a review from an exam. Sound good? Next class, we will start our next section, which, sorry, I'm going to interrupt here. I'm going to bring it up real quick. I want to see where we are. Schedule. I think we're somewhat caught up. Not really. No, we're not. So today is the 23rd. So next class, next week, we're a week behind, 1 week behind. We'll start 3.5. I might decide not to. No, we need it. I'm going to just do real quick on that. And then L'Hopital's rule. So L'Hopital's rule is very important, so we want to make sure we spend the full 2 days on that. Okay? Somewhere. Where is it? There we go. Come on. Okay. All right, I'm going to go ahead and shut the video down, but y'all get to work on this. Again, if anyone wants to pick up their Exam 1 corrections, they're up here. And there's also some old quizzes up here. Remember, when you're done, just bring it up to me and I'll take a look to see if it's right.